In probability, one needs to know how to count the number of elements of sample spaces and the number of elements of an event. It is important to learn fundamental principle of counting, permutations, and combinations. In this particular video, we shall first discuss the fundamental principle of counting. The first principle of counting is the multiplication rule. This is used whenever a statistical experiment consists of a conjunction of two events. This states that if an event capital M can occur in small m ways and event capital N can occur in small n ways, then event capital M followed by event capital N can occur in small m times small n ways. Let us have an example. A certain shoe comes in 5 different styles with each style available in 4 distinct colors. If the store wishes to display pairs of these shoes showing all of its various styles and colors, how many different pairs would the store have on display? So in this case, now there are 5 different styles. Let's label them with S1, S2, S3, S4, and S5. And for each of these styles, there would be 4 distinct colors. So for each style, this will branch out into 4 additional outcomes, which corresponds to the 4 different colors. Which means that if we're going to use multiplication, we get 5 times 4, which is 20. Therefore, there would be 20 different pairs that the store would have on display. Another example, in a hospital, patients are grouped according to their gender, male and female, and blood types, A, B, blood type AB, and blood type O. How many groups of patients are possible? So in this case, we have 2 genders, which are male and female. Each of these gender would branch out into the 4 different blood types, which corresponds to A, B, AB, and O. Using multiplication rule, we have 2 times 4 equals 8 different groups of patients that are possible. If a statistical experiment is obtained by the conjunction of 3 or more events, then we shall use the generalized multiplication rule. If an event capital M sub 1 can occur in small m sub 1 ways, event capital M sub 2 can occur in small m sub 2 ways, up to event capital M sub k can occur in small m sub k ways, then event capital M sub 1 followed by event capital M sub 2, and so on and so forth up to the event capital M sub k can occur in small m sub 1 times small m sub 2 times up to times m sub k ways. Let's illustrate the generalized multiplication rule. A developer of a new subdivision offers a prospective home buyer a choice of 4 designs, 3 different heating systems, a garage or carport, and a patio or screen porch. How many different plans are available to the buyer? In this case, there are 4 events. The home buyer shall choose one from each event. The home buyer has 4 designs to choose from, D1, D2, D3, and D4. And then the home buyer will choose among the 3 different heating systems, which can be represented by H1, H2, and H3. And each of these will branch out into either the garage or carport, and each of these will branch out into either the patio or screen porch. Therefore, using the generalized multiplication rule, we have 4 times 3 times 2 times 2, which is equal to 48 different plans available to the buyer. Another example would be the digits 1, 2, 3, 4, and 5 are to be used in a 4-digit ID card. How many different cards are possible if repetition of digits are permitted? Since we are forming a 4-digit number, we need to determine the number of possible digits that can be used for each position. So in the first position, we can use any of the 5 digits given in the problem. Now, since repetition of digits are permitted, we can still use any of the 5 digits given in the problem for the second position. That goes true as well for the third and the fourth position. So using the generalized multiplication rule, we get the product of these values and we get 625 4-digit ID cards where repetitions are permitted. Now in the second scenario, repetition of digits are not permitted. So when we form the 4-digit ID card, the first position may have 5 of the digits given in the problem. And since we already used one digit in the first position, we only have 4 choices left for the second position. Now for the third position, we have 3 choices left. And for the last position, we have 2 choices left. So using the generalized multiplication rule, we get 120 4-digit ID card where repetition of digits are not permitted. Let's have a slightly challenging example. How many 3-digit numbers can be formed from the digits 0 to 9 that are greater than 600 if digits cannot be used more than once? Since we are forming a 3-digit number that is greater than 600, then the first position must have 6, 7, 8, or 9. So we have only 4 choices for the first position. Now whatever we used in the first position cannot be used anymore for the second position. So originally we have 10 digits to choose from, but since one of these digits was already used in the first position, we only have 9 left for the second position. Now for the third position, since we already used 2 of the 10 digits, then the third position will only have 8 choices left. So therefore, using the generalized multiplication rule, we have 4 times 9 times 8. You can manage to get the product of this problem. So now you have learned about the fundamental principle of counting, which involves the multiplication rule and the generalized multiplication rule. In the next video, we shall discuss other counting techniques that would involve arranging and selecting of objects, which can be solved using permutations and combinations.